Ladies and gentlemen, welcome back to the channel. Today in our studio, I would like to show you how we can run classification using neural network. Among the packages, there are some neural network packages. The MNet is offered by default, but I personally like a bit better the neural net package, and today I will show you how it is working. So we start with the neural net package, and using it is very simple because we can create one model, neural network model, with the function neural net, and it works like any other classification. You can see that there is a formula, a data, and why I like it very much that there is an option we can define the hidden layers of the network. So the classification formula will use now the iris data table, the common example. So the species column will be classified against all the others data from the table of iris. And the hidden layers will be, let's say, 2 layers with 2 and 2 neurons in each layer. So this is how the model is created, and if I run it, you can see the computer was thinking a little bit, and now I have already a model. If I want to get my prediction how the classes were recognized, I get a predicted value from the predict function. I use the model number 1 on data of iris, the table. And here comes the problem. When you see the neural network result, I have 150 answers like it is in the iris table, where we have 150 measurements. And for the 3 classes, I have 3 different columns representing a score, and the maximum score, the highest score, will go to the selected class. So if I check how it looks like, for example, the first 3 rows of it, you can see that at the beginning the first class was selected because of the highest score and the others are much less. So this makes it a little bit difficult to evaluate it automatically. I propose to use a classification function for neural network model. So I will create a neural network classify function with 3 parameters. My model will be the first one, which model I want to use. Then my data, the complete data table, and then my class, what are the classes I try to classify. And then I can collect all the information from it. First, I need the predicted value. Because it is inside the function, it doesn't make conflict with the outside parameter. This will disappear when we finish running the function. So I calculate the predicted values from my model on my data. The separation of this function from the model creation is very useful because the data and the classes can come from any other, even from a validation separate data set. So predicted scores came here. And after that, I need to know what are the data or class levels in this table. In iris dataset, if you remember maybe from other examples, there are 3 different flower species, Cetusa versicolor virginica. So the data levels will be the levels of my class at this moment. And after that, we know this, we can start calculating the results. Calculating the answers. So first, I will make a placeholder for the answers, and the answers will be filled with not assigned values for the length of my class vector. Okay, so now I will have a placeholder, and if I cannot identify any class and NA not assigned is remaining, then we know that there is a problem with the evaluation. So we do not expect at the end any not assigned will remain. Let's check what are the answers. To know it, I have to select from this table where is the maximum, which column represented. So I have to calculate the maximum values. I will use the apply function to calculate from the predicted table for each row using the function of maximum, the maximum values. Okay, so get maximum values for each row. And after that, we know where are the maximum. We can start filling the answers with the correct evaluation based on the neural network prediction. So how we can know it? Fill answers with prediction. So I will have an index from 1 to the length of the data levels. So for all classes, we will evaluate it. Actually, this is the number of the columns as well in the prediction, hopefully. So when we have it, then for each time, the answers will be modified the way that the answers, the predicted value for the index column equals to the maximum value, then the answers will be provided with the correct number. It can be the index number which column represented, but I have a better idea. If I already have the data levels, I can fill it with that. So basically, each answer will contain the name of the class instead of just an index number to identify. And after that, we can do the evaluation. Because the answers are filled already, we can make a confusion matrix. It is pretty common to calculate it. We can get a table of the original my classes, the observations against the answers, the predictions from the neural network. And to be very clear, I will make a dimension numbering. I will define which is which. The first will represent the observations. Observed data are there. And then the second will be the prediction from the neural network predicted. Okay, now I'm ready with the confusion table. And how I know the accuracy? Actually, the accuracy could be the diagonal summary against the full table. But what happens if a class is missing? So the diagonal calculation is not always very safe. I will make a comparison vector. A comparison vector full of 0 for the length of the answers. For example, my class, the same. And then everywhere where the answers and the classes agree, I will change it. So where my class agree with the answers, I will change it to value number 1. So after that, the accuracy will be the summary of the correct answers compared to the whole one. So the summary of the comparison against the length of the comparison will give us the accuracy. Now I have all information. I just have to return it to know what we have done. It will be a list because we have several different type of data here. A list of correct recognition, the accuracy, the confusion, matrix and the list of answers. So the answers will be the calculated answers, the prediction from the neural network. The confusion matrix, confusion matrix will be the confusion table, and then the accuracy will be the calculated accuracy. So let's check I didn't make any mistake in typing in things. So if I run it, okay, it seems I didn't do any mistake in typing in the comments. And now the evaluation will be very simple. I already have model number 1. So the results will be the NN classify function using model number 1 on data table of iris with the classes of iris species column. Okay, so this way I will have the results. And now you can already see what are the results here, the confusion matrix, the accuracy, and then here are the answers. So, no, I made a mistake. I need double equation here because I recognize the accuracy is wrong. So, okay, it's too low. Now, correct it, and then when I run it, yeah, it's much better. It was a lower value here. Now, if I just check how it is, I can print, for example, the results confusion matrix. You have seen that the names I given here are options, and I can check. This is the confusion matrix, and now it is super clear that the rows represent the observations and the columns represent the predictions from the neural network. There was only one mistake. So I can also print what was the value of the accuracy, and now it is 99.33 percentage. It is very nice. What will happen if I modify the neural network? For example, somebody would like to test different topology, how many hidden layers, how many neurons we need. So I will create a second neural network. I'm lazy, I will copy from the top. And let's see what can do the neural network with only one neuron in one hidden layer. This will be a second network. And now if I repeat the evaluation, I just have to modify the model inside. Model number 2 I use, and then you can see that, oops, already one class is missing from the recognition of the neural network. So if I would calculate the diagonal values, it will be a problem. There is no diagonal value here, actually. It's not a 3 times 3 matrix, and then the accuracy is lower. So this is a safe calculation way, and you can see how it is working. Let's check what happens if I make, for example, a more complicated neural network. Maybe I increase the number of the neurons, but what you have to understand with neural networks, that every time we create a neural network, it is initialized with random numbers. So all neural networks are unique. If I just repeat the neural network, the previous one again, it will be a completely new neural network. So let's check how it is. Now I have 2 layers with 3 and 2 neurons in one of them. The first layer with 3, the second layer with 2 neurons, and then its classification, oh, the same. It seems that I still have one mistake here. Okay, so now you have seen how the neural network classification is working, and now you can see a nice function to help you run the evaluation automatically and get the results in a very comfortable way. Thank you for your attention. I hope you enjoy. Have fun.